In problem 4, we have a tank containing 125 gallons of heating oil at time t equals 0, and during the time interval from 0 to 12 hours, heating oil is pumped into the tank at a rate of h of t, so many gallons per hour, and during the same time interval, heating oil is removed from the tank at the rate of r of t, is so many gallons per hour. We want to know, first of all, how many gallons of heating oil are pumped into the tank during the time interval from 0 to 12 hours. So I enter my two functions into the graphing calculator, just making sure that I get all the parentheses in there correctly. Now, how many gallons of heating oil are pumped into the tank from 0 to 12 hours? That is going to be y1, and I want the integral from 0 to 12. So in this case, I'm going to go out to the home screen, and I'm going to do math, option number 9, which is fnint, vars, y-vars, function y1, comma x, and comma 0 to 12. That gives me 70.571 gallons. Next question we're asked then is the level of heating oil in the tank rising or falling at time t equals 6 hours? Well, the level is going to be determined by how much comes in versus how much goes out. How much we start with plus how much comes in minus how much goes out, or has come in and gone out up to a certain point in time. So there's a couple of ways of looking at this. And one is to define the function L of x, which would be basically what I just said. We start with how do we know the level? We start with how much was in the tank originally, then we take the integral of the rate at which oil is being added minus the integral of the rate at which oil is leaving the tank. And if we want to find out whether the level is rising or falling, we're looking for the derivative of that. And since the derivative of a constant is 0, we're basically just looking for the derivative of the integral from 0 to t of h of x minus r of x dx, which is just h of t minus r of t. And that really makes sense logically, because whether or not the level, regardless of how much was in there at the beginning, if the level is rising, it will be because more oil at that instant is being added than oil is leaving, and that will give us a net change and an increase in the level. And vice versa, if more is leaving than entering at any point in time, regardless of how much is in there at that moment in time, the level will decrease. And so to find the rate of change in the level at time t equals 6, I'm going to go ahead and add a third function, which is the difference between y1 and y2, or which is h of t minus r of t. I'm going to come back out to the main screen and do vars, y-vars, function y3 of 6, and that gives me negative 2.924. And because that derivative is negative, then that means that we have more oil leaving at that instant in time than is entering, and so the level is falling. Now, since we've already defined L of t, if I'm looking for L of 12 in part C, I can just do fnint of y3 and then add 125 to that. But I've already defined L of t above, so I don't need to go through writing that all over again. And so I had to do fnint with y3. Variable of integration is x from 0 to 12, and that gave me negative 0.2974. But that's just the change over that 12 hours. I still want to add that to 125 that was in there originally, and I come up with 122.026 gallons. And we'll do part D in the next video. That's basically asking at what time is the volume of heating oil in the tank at its least.